Welcome to episode 8 with Blades, and let's get on with it. We're going to do this move snake, aren't we? Yes. I left you with a problem. A computer that's too fast. Computers being too fast for games? Yes, indeed. It's a known problem these days. It's making things that don't sneeze, for instance. And let's have a look. Yep, left arrow, uncontrollable. It's looking a little bit not very good. So, what can we do about it? It's why I have these two lines here on 9 and 10. Inhibit right and inhibit left equal to false. What I'm going to do here is put the logical AND, which is two AND signs, ampersand signs, and then I'm going to put in not underscore inhibit left. It is a little bit simple, I know, but it works. So all I need to do at the end of all of this, I'll put some notes in by the way for myself because I'm going to forget otherwise, is underscore inhibit left equals true. Sounds good so far. Problem is, it will then stay true. So we need an else if. We need to reset it, really, to be honest with you. Underscore window. What are we on? Dots nowadays? Yeah, dots is key pressed. And it's GLFW key left. Underscore left. It's not coming up, okay. No. GLFW key left, yeah, that's right. Is equal to false. In other words, it's not being pressed. Then all we have to do is put inhibit left equals false again. Let's reset it back to false so we can do another left arrow key. So for each one press, it should now go left once. Let's try it. Let's just try that out and find out. The right key isn't inhibited, the left key is. Let's have a look at the difference now. Left key, 1, 2, 3, press, 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 keep down, nothing. Right key whizzes around, left key will only go 1. Just by a simple inhibitor. What really that inhibitor does is stop multiple key presses by setting inhibit left true. You can keep going through this and going through this with the left key going, being pressed down, but it will only ever satisfy that condition once. Once you have released the key, that becomes true. It resets your inhibitor, so you are then ready to press the key again, and it will only then satisfy that once. So I better do it to the right key, I think, as well. Otherwise, the right key will never work. So this one is an and, not. That's right, not underscore inhibit, and it's right this time. Then down at the bottom here, all we do is set it to true. Very simple. Nothing technically strange, or it's just a pure piece of logic to make sure that something only happens once. That's all we've done. So else if underscore window is key pressed, and this time it's GLFW and it's key. I always worry about this bit not working properly, but it seems to be doing now. I don't understand it. And then it's right. There it is. Yeah, see, it comes up this time. And we'll just put that equal to false. Sorry, that is equivalent to false. The logical equal sign. Doubling it up. Anytime you see a sign like that doubled up in C++, it means it's probably a logical function to do with logistics rather than anything else. Inhibit right equals false. There we go. So now, when we test it, our key should work. One press equals one turn or one movement of 90 degrees. So left works nicely now, and right works nicely. Hold the key down, only happens once. Hold the key down, only happens once. Lovely. Yeah, that's how we solve the problem. So that is the correct way of doing it. The other problem we have is we don't know which direction it's facing in. And it's something that we could keep track of, or we could. I have played around with the thought of using this number. Probably could, but I'm going to do something simple. Go to this one first. So south, as we've discussed so far, X, Y, Z. If you're facing south, you are facing +1. If you're facing east, you are facing +1, but in the X direction. So we're only using the X and the Z directions. Minus Z equals north, minus X equals west. I'm just going to represent those with ones and minus ones to make it easy for myself. What we're going to do is say if M underscore move direction Z, I think we need for this one, yep, dot Z, is equal to a 1.0f, then what we're going to do is we're going to turn it, because we know we're turning it by 90 degrees, so the M move direction equals, and we'll just set it straight to vec3. And that vec3 will be 90 degrees to the left, which is east. Yep, that's right, so that's 1.0f, 0.0f. So that's 90 degrees to the left now. So our move direction will follow the current rotation with a simplistic way of doing it, just using how can you put it, a vector 3 to keep track of it. Else if underscore move direction, and you can see what's going to happen here. It's dot x is equal to 1, and it'll go through to north. It's an F, isn't it? There we go. Sorry, brain malfunction. Oh dear. It's already started. Equals. And go on vec3. So really this is just setting things up. So now I wanted to go to -1, don't I? Yeah. 0.0f. 0.0f. And then it's -1.0f. And it is literally that simple. And then we can do the north one. And it's repetition. It's like anything else. Once you've got the simple part, it's easy. Is equal to -1.0f, and it's facing north, or was facing north, and we've just hit the key, so it's now move direction west. Yeah, that's right. And the cat's going to sleep on my arm. Thank you, cat. That's useful. So west is -1, naught, comma, naught. There we are. Nothing overcomplicated. And of course, if it's west, it's going to turn to south. So just the last else. If, only need the 4. It's got to be one of them. And that is x is equal to -1. And then we will move direction, just turn it around back to the south. Yep, that sounds good. Back 3 and south is 0, 0, 1. And the last one being 1.0f. So that's the full cycle. That's the 4 directions it can equal. And when you hit the left key, that's the way we want it to cycle. So that's that bit done. And may as well copy it, to be honest. And paste it in here. The difference is now, when it's going to south, we want it to go to east. Sorry, west. So we want it to go in the reverse. So instead of 1, I want that as a -1. So the key to this is, let's have a look. I can't remember these. So it's -1, and then it's -1 again. Let me just make sure I'm doing the right one. So east will go to 1. Just take that off. North will go to 1. And west will go to a -1 again. It literally just reverses the directions. Yeah. So you just reverse the directions. That's all. So you have a look at the pair of them. 1, -1, -1, 1, -1, 1, 1, -1. Yeah, it's reversed. And our inhibits are in. Everything's done. Final movement's up. Let's get on with it. Nice. So now our directions are all correct. So we've used our inhibitors. We've used our direction movement. Current segment 0 still, because we haven't grown it. Yeah. Looking good. And current rotation starts at 0. Yeah, the 0, 0 being south. Neat. Let's have some coffee on that one. That was a nice little enjoyable bit of programming because it's nice and clean. Here we go. Collisions. You'll hear about this a lot in game programming. You've got to detect your collisions, and they call it collision detection. Well, sometimes it is, sometimes it isn't. We're on a lucky game, a nice easy one, because collision detections really mean checking in with other stuff. So we'll have a bool. true or false, and it's going to be called collided. And to start off with, we'll just put it to false. Straightforward. There are no collisions, it hasn't collided, that's fine. The thing we're going to return is collided. So no longer false. Let's have a proper thingy. Collision with the map board is pretty simple. How many map boards have we got? 4. So if pos we're passing in, pos dot x is less than or equal to 0.4, it has to be a number below 0.5, anything will do really. 0.4 I'll call it f. And now we're going to use the logical OR, which is a horrible sign. It's 2 straight lines going down. It's next to the Z key on a British keyboard. Shift backslash. We get that, and it's fine. Let's have a look. Pos dot x. So any of these conditions, if any of them are true, then it's outside of the boundaries of the map, is what we're looking at here. Greater than or equal to map size 30, so that's 29.6 f. So if it's greater than that, or new line please, thanks. And then it's just going to be pos z, because we don't do y, remember? Y is up. I'll make this one a less than, oh, same things, isn't it? 0.4. And then we just got that or pos dot z is greater than or equal. We're just checking it for the same numbers. 29.6. So if any of those values are true, this will happen. A collision with the map border will be true. So all we're going to do is at the end of that is just set collided equals true. If any of those are true, then collided is true. Not a problem with that. Collision with a snake. We don't know what size a snake is, do we? Yes, we do. It's current segments. So what I'm going to do is I'm going to just create a variable. And it's going to be a vec3. And it's going to be head. And that equals whatever the snake position is. Snake's head position is snake. Which is, there we go, get player position. There we go. We've got it here. So it's as simple as that. We'll do that. Then what we're going to do is int I equals m current segments. Now this is where I'm not sure whether we really need this. I'm going to put it in anyway, because this also is given by snake. But are we actually setting it? Because this is a tail. Let's have a look. You've got set num segments, and we have get num segments. I'm going to put that in to see if we can get rid of this silly variable, which I seem to have placed in, which I'm not sure we really need. I mean, I might have just put it in for ease, but get num segments, m snake. Let's just have a quick look at me snake. Snake. Num segments equals 0, 0, yeah, that's happy there. Enum segments plus plus. We are actually increasing it as we are increasing. So that's being done automatically under grow. Okay, as long as I know it's automatic, then that's fine. So right, we've got the number of segments, which is 0 at the start of the game. We've got the player position, which is where we stuck it at the start of the game, and we're going to do a little trick. I'm going to do a while loop. Now, the trick is it doesn't include the head, because we're going to put greater than 0. That's right. So get number of segments is the total length of the snake, and we count the player position 0 as the head. So that's not equal to 0, that's greater than 0. Interesting. So how is this going to work? What we're going to do is take Amber, vec3, and we're going to call this one tail, equals m underscore snake, and it's get segment. And this needs I, needs to know which one. So we're going to get the segment. It should be get segment position, surely. Yeah, that's better. That works for me. This is a little bit more tricky of an if statement than you may initially think, because it's double open brackets. It's headaches, not headaches. Headaches is equal to tail. Really should use fuzzy logic here. There is a way of doing that. Not bothering because we're using whole numbers virtually everywhere. So it's going to work out, and it's got to both equals. It's got to satisfy both the x and the z. Head.z is equal to tail.z. And then we have collided equals true. And that can happen for any segment. We could collide with any segment. Now, one of the tricks with this is, will the head collide with the very last segment of the tail? And the answer is, it's difficult to test. But the answer is, yes, it will. When does that collision occur? Before or after movement? That's the problem. You've got to really check after movement has been completed. Because when we are going to move the snake, we have to go from the last segment to the head to move it. Because if you remember, the snake doesn't alter its track. It sort of like follows what's gone before. So we always have to move the last piece first. That should be fun. Grow snake. I'm not happy with this one yet, am I? Not sure. Let's because we have grow. So really, if I'm not using m current segments, I've just taken out of that piece, haven't I? I think I have. Let me just make sure I have. Yeah, I have. Because I've got no reason to use m current segments at this point in time. So, increase the number of segments, grow snake. Let's see what we can do for that. So we can do something more sensible than I originally wrote. What we do is m underscore snake, grow. Remember that increases. There we go. Grow takes the segment number. Yeah, so that will be m underscore player m underscore snake get num segments plus 1. So that will be the first part. And the second part is we need to get the position of the current segment. Okay, yeah. Now where do we get that from? That's just going to be m underscore snake. I'm trying to do this without using m current segments at that variable, just to see how it looks. If it looks really stupidly, get segment position I want, that one. And that will just be that number. Okay. So what we really have here is int num segments equals m underscore snake arrow get num segments. What's wrong with that? Oh, just call it segments. That we can then copy out and replace that. Get segment position, and that becomes segments, like that. There we go. So what we're going to actually set it to is the current segment. However long it is, we are going to put on top of the last segment an extra segment, which won't move. The first time the snake moves, it won't move. So after growing the snake, the next time through the movement, the final movement stage that you're about to see here, that last piece will not move, and that will then lengthen the snake out, and then it'll start following after that. So it's like a delayed reaction, but it is happening. We are growing a snake, but we grow it, and then it moves. But it has to move to grow. It's because of the way we're going to do the final movement. It's quite an interesting aspect of the way we're using the movement to grow the snake, and it works, but it just looks weird. Right, what else do I need to know here? Right, grow increases the number of segments automatically. We've already checked that. And we need to alter the movement speed. Right, yeah. That's all we need to alter, isn't it, when we grow? It goes faster. So m underscore move speed equals, no, we'll have minus equals, just pick a value. 0.3 sounds good. 0.3f. That'll give us 50 segments to max speed. My calculations are right. Probably not, but sounds good. I think it's right. And that's it. That's all we need to do. Oh, lovely. Nice cup of coffee. Let's move these segments around, shall we? That should work. I've missed out using 2 variables there. One is M segments, and so current segments can now remove because we're not using it, and M segments we can now remove because we're not using it. Excellent, that's 2 down. I hope. There we go. It's quite strange how people can get fixated with the way the coding goes, and so far this has looked a lot simpler. Because I'm using snake now to get all of my bits and bobs rather than I'm using something we've already got rather than inventing something new to take care of it, which is a bad habit I've got for inventing variables that just really are useless. You know, it's crazy. M countdown. Yes, we do need this one. This is your final movement. As I said, we've got to go from back to front. So countdown is going to be minus M underscore countdown. So that always goes down 1 at the beginning. There we go. Every time we come through final movement, we do a countdown until we move, and then we reset it. So do that first. So if we can't obviously move it every single time it comes through final movement, because if we did, you saw how fast it turned. It would be just silly. So when our countdown is less than or equal to 0, I think, is it minus M countdown, or is it M countdown minus equals speed? What have I done with the speed here? Have I even put it in? Have I used it? Yeah. I get you. Okay, let's try this out. It looks right, but I've got to be careful when coding like this, because if I don't juggle it right, it will mess everything up. So now that we're inside the if statement, we can move the segments. So int I equals M underscore snake. Yeah, this is going to look a bit weird as well, because we're going to use exactly the same trick we used above here with the wild thingy, and it's getting num segments, isn't it? Yeah. So that tells us how long it is, and all we've got to do is while I is greater than 0. Remember, the head isn't counted as a segment and must be moved separately. It's the only thing that actually gets a new position. Everything else gets an old position. So here everything else is. So M snake, and what we're going to do is set the segment position. That's the bottom one. And it needs to know which one. So that's going to be I. So it knows which one. And then we need a position. And it equals the position of the previous segment, or head, depending. So it is M underscore snake, and it's get position. Get segment position, that one is that. That's the one we wanted. And it's I minus 1, comma, no comma. Okay. I minus 1. That's it. Looks easier than I thought. So what we're doing is we're taking the previous position and giving it to this current item. So we're going back to front, and that's the whole point. M segments we don't need, I minus we do need, for obvious reasons. Otherwise the whole thing won't work. There we go. So when that gets to 0, the head, it'll stop. And that means we have to do the head here. And this is where this move direction comes in. So why was I doing all of this move directions with 1s and minus 1s? Because we're going to add it in here. This is where it matters. And it is... Right, okay, that's alright. I'm going to have to invent this, aren't I? Snake. No, it's, yeah, M snake. What we got? What can we do? Oh, we can set player position. And that'll need a vec3. This will need a vec3. No, I don't like this. I don't like this at all. I need the current position. Because by the time this has gone through the while loop, the segment will have gone to the head's position. So we need to move the head on. Let's say that head equals that. Instead. So a vec3 equals get player position. Is that okay? No. That is. What I need to do now is move it. So head.x dot x plus equals m underscore move direction x. Yep, that's right. Yep, we're allowed to do it as well. I'm happy about that. Head dot z plus equals m underscore move direction dot z. If they're equal to 0, minus 1, 1, doesn't really matter. They must be equal to something, that's okay. So now we've got that, the new position, we just type in m, it's obvious what we do now, m snake, set player position, and it's a new position which is head. There we go. Last thing we want to do is to reset our countdown. Let's have a look what we can do here. M underscore countdown equals m underscore move speed. As you can see, that gets lower every time we grow. That's where the move speed comes in. That's a nice way of doing it. So there we have it. This now means that our snake should move. It'll be a bit blocky, but it's not going to be a smooth movement. It's going to be jumping by 1. Will it? Oh no. See if our arrow keys work now. Yeah, we're moving. Collision check? None. Okay. What about border check? None. It's not happening. Because we're not checking collisions. Yeah, but we've got the movement. Right, so I know I'm not checking collisions, that's obvious. Lovely. We've got movement. All we need to do now is check collisions, and that is the story of game logic. It's game logic that's got to do it. So that is roughly what I'm going to set out as being move snake, all of that lot. Now we have to find out whether it works. We know that the movement's working. Well, I wasn't going to even doubt that part. I think that should do it. Looks complicated on the logic side, but it isn't. It's all simple logistics. It's all simple plus or minus ones in each direction, and then just making sure it goes on here. The while loop, collided, yeah. How to grow the snake, yeah. How to do the final movement, which is repeating up the snake until you get to the head, and then continuing on. But you can see how the movement is now working. That's good. Move snake's done, I believe, at this point. We'll see. We'll see, because in our next episode we are going to revisit game logic again, and I think we might need some game logic here, because we haven't even checked the goals reach and stuff like that, and respawns and stuff. We'll do that. How's about that then? So until then, take care, catch you later, and have fun.